Good morning, grade 12 learners. My name is Mohapi, Mathematics Subject Advisor in Motao District. So today I'm here to take you through the test that will be written on the 19th of April 2021. The purpose for presentation today is to outline exactly what to expect in this formal test for Term 1. Remember, like I said earlier, this formal test will be written on the 19th of April 2021. 19th of April, all the grade 12 learners will then be sitting for this formal assessment task. It's very much important to prepare thoroughly because this test will then contribute 10% towards your SBA, school-based assessment marks. So it's very much important. We need to prepare thoroughly, and you also it serves you well because at the same time, it gives you an opportunity to evaluate yourself, to check how far are you, how developed you are in mathematics, how ready are you in the topics that will be tested in this coming test. Fine. As we carry on, the test, like I said, it will be written on the 19th of April, and it will be based on 3 topics. The topics are sequences and series, Euclidean Geometry, and Trigonometry. I hope it's clear. Grade 12 learners, I'm taking you through the test that will be written on the 19th of April. So I want you to be ready. I want you to be ready. So these are the 3 topics that will be tested in this upcoming test. Sequences and series, Euclidean Geometry, and Trigonometry. Fine. Let me take the first topic, which is sequences and series. And then, what is it that we are going to, or should we expect in the sequences and series? Remember, sequences and series, basically it's patterns, number patterns. Patterns is sequences and series. Patterns, we start from the linear number pattern, quadratic number pattern, and the geometric. Let me take you through the scope. In sequences and series, what can we expect? Sequences and series. Let's check the type of questions that we can expect. Look at this first question. It's about 4 marks. The first 4 terms of a quadratic pattern, 15, 29, 41, 51. Those are the first 4 terms of a quadratic pattern. It's clearly stated that this is a quadratic number pattern. It is a quadratic number pattern. Being a quadratic number pattern, then you must know as a grade 12 learner what a quadratic number pattern is. By definition, we defined a quadratic number pattern as a pattern in which the second difference is common. This therefore means we need to determine the first difference. After determining the first difference, and then we determine the second difference. Because it's a quadratic number pattern, the first difference will always yield a linear pattern. The first difference will always yield a linear pattern. Or we can simply say arithmetic sequence. The first difference always gives you an arithmetic sequence. And then the second difference will then be common. So, for instance, the first question, write down the value of the 5th term. Check the sequence. You are given the term number 1, which is 15, term number 2, which is 29, term number 3, which is 41, term number 5, which is 51. Then you must then determine the value of the 5th term just for 1 mark. These are the possible questions that we should expect. So how do we determine the first term? Remember the first difference. 29 minus 15. 41 minus 29. 51 minus 41. Those are the differences. I repeat, the first difference, 29 subtract 15. I think it will give you 14. 41 minus 29. It will give you 12. 51 minus 41, it will give you 10. Already the first difference gives you 12, gives you 14, 12, 10. So it shows that the the first difference is a linear pattern, of which the common difference will be 2. Now you will then determine the second difference. Once you have done that, then it's easy for you to determine the value of the fifth term. I'm just trying to outline or to indicate to you what to expect in this upcoming test. Check question 1.1.2. Determine an expression for the nth term of the pattern in the form Tn squared to an squared plus bn plus c. The nth term, it means for you to be able to determine the value of the nth term, firstly, you need to determine the value of a. Check inside here, you need to determine the value of a. I've highlighted it. You need to determine the value of a. How do we determine the value of a? There are various methods, but the most commonly used method is the one that states 2a will be equals to the second difference. 2a equals to second difference. In this case, our second difference will be -2. So 2a will be equals to -2. Dividing by 2 both sides, you've got the value of a as -1. After determining the value of a, then it means you must then come and determine the value of b. How do we determine the value of b? Remember the formula, 3a plus b will give you the first term of the first difference. 3a plus b is equals to the first term of the first difference. 3a plus b is equals to the first term of the first difference. You already got the value of a, so it's easy to work out the value of b. Check, how do we determine c? Constant term c. More often, the formula that we use to determine the value of c is a plus b plus c is equals to the first term of the quadratic pattern. A plus b plus c is equals to the first term of the quadratic pattern. And in this case, the first term of the quadratic pattern is 15. So you say a plus b plus c is equals to 15. Then you already have the value of a, you already have the value of b. It becomes easy for you to work out the value of c. I'm here to give grade 12 learners an idea of what to expect in this upcoming test, which should be written on the 19th of April. So, quadratic pattern is one of the topics that will be examined, that will be tested. So this is more or less what one should expect in quadratic pattern. Check this one. The value of T27. Already from 1.1.2, you have already determined the nth term. So all you have to do, if you determine the value of T27, you need to substitute n by 27. In this nth term that you shall have obtained in 1.1.2, you just have to substitute n by 27. Then the question will be answered. Grade 12 learners, I know for this year we're focusing mainly on arithmetic and geometric, but this is part of pattern. Remember, mathematics is one subject where all grade 10, grade 11 content is still tested in grade 12. All grade 10 and grade 11 content will still be examined. Even at the end of the year, grade 10 and grade 11 concepts will still be examined. Basically, you normally say 55% of the grade 12 question paper is mainly grade 10 and 11. So this is what one should expect under quadratic pattern. Let me take you through another example of a quadratic pattern. Check this one. Given the quadratic pattern 5, 10, 17, 27. Grade 12 learners, I'm just giving you an idea so that you must know how to prepare for a test. Write down the next 2 terms of the pattern. In the previous activity, it was just write down the 5th term. But now we need to write down the 5th term and the 6th term. Check 3.1.2. Determine the formula for the nth term of the pattern. Exactly the same like the previous one. Check 3.1.3. Which term of the pattern will have a value of 1,765? How do we approach this one? The nth term that we have determined in 3.1.2. You then equate it to 1765. The nth term you have determined in 3.1.2, you equate it to 1765. But after equating, then you write the equation in the standard form, meaning you transpose 1765 to the other side so that it can only be left with 0 on one side. And then you factorize. How do we factorize? Because it's a very big number. More often, it is advisable to use a quadratic formula. It is advisable to use a quadratic formula. Grade 12 learners, even grade 12 teachers, maybe I should remind you that from time to time, we need to practice our learners. Give them the opportunity to use the formula sheet, because once we have this 3.1.3 written in the standard form, we've got 1765. It's a very big number, so it becomes difficult for learners to factorize. So to make it easy for them, allow them to use a quadratic formula. So when you write a test, a formula sheet will be attached at the back of the question paper. So you just have to look at the formula at the back of the question paper, you come across a formula sheet, and then you write down the quadratic formula, which will be x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. And then you work out your solution. Remember, as you work n, because you talk about Tn, which is equal to an squared plus bn plus c. N always represents the position of a term in a sequence. Let me repeat that one. The nth term of a quadratic pattern is given as Tn, which is equal to an squared plus bn plus c. That is the nth term. What is the role of n in that question? N indicates or denotes or represents the position of a term in a sequence. So which term of the pattern will have a value of that? It means n will always be a natural number. Once you have two values, and if the two values are natural numbers, then both answers holds. Both answers will hold. But if you have a quadratic pattern, and then quadratic equation, you solve, you've got two values of n, one should be a natural number, the other one can be a fraction or a negative number, anything, then you have to indicate that that one is invalid. The only correct one is the natural number. Let me repeat myself for the last time. If you determine n, you'll have two values, because it's a quadratic, you'll have two values. And both values, we expect them to be natural numbers. If both values are natural numbers, then that will be the solution for n. We accept both values. But if one value is negative, or if one value is a fraction, then the other value will definitely be a natural number. Then that fraction or that negative number will have to be rejected. You need to indicate as a grade 12 learner that the only solution here will be that n value, which is equal to a natural number. Thank you. I want to take you through one last activity on quadratic number pattern. I think it's question 7. Look at this question 7. Given the quadratic sequence 321, 290, 261, 234. Write down the values of the next two terms of the sequence. If you can check in all the activities that I've shown you, every time you will be expected to write down the next two or the fifth term or so. So please prepare thoroughly. Determine the general term. You see the general term here, it is Tn is equal to an squared plus bn plus c. That is our nth term, the general term. Which term of the sequence will have a value of 74? So it means you substitute Tn by 74, and then you work out the value of n, exactly what I've just explained. And then you solve the quadratic equation. Remember, for you to solve the quadratic equation, first write the equation in the standard form, and then you factorize. If you cannot factorize, use quadratic formula. We have scientific calculators that can work out fractions, so it's easy to just punch in the values in the formula. Just insert the numbers in the calculator, and then the calculator will give you the solution. It's not difficult work. Practice makes perfect. If you practice regularly, you will see this is not difficult, because you can just use a quadratic formula. 7.1.4. Which term in the sequence has the least value? You see, it's an squared plus bn plus c. It's a quadratic formula, the nth term of a quadratic pattern. This quadratic pattern is very much, its behavior is similar to the behavior of a quadratic function. So if a is negative, the quadratic function normally faces downwards. Then it means the turning point of the quadratic function will then give you the maximum value. If a is negative, the turning point of the parabola will then give you the maximum value. In this case, the question 7.1.4 requires you to determine the least value. No, meaning the value of a here definitely will be positive. Now, our parabola will face upwards. So the minimum turning point there, the y value for the turning point will give you the least value. So that is how functions are linked to quadratic patterns. Remember, more often than not, we'll see that integration of concepts. We're talking of the quadratic number pattern here. Now we bring in determining the least value. Boils down to the properties of quadratic functions. When a is positive, the quadratic function faces upwards, so you've got the least value, which is the minimum turning point. Thank you very much. These are some of the questions that we should expect on patterns, sequences, and series. And up to this point, I've only been talking to you about a quadratic pattern. Remember, we also have the arithmetic and the geometric. Let me take you through some of the questions that you can expect. Let's start with question 2. Check this one. Check question 1.2. Given a geometric sequence, 3, 36, negative 18, 9. It is a geometric sequence. Determine the value of r. Remember, a geometric sequence is a sequence in which there is a constant term between successive values. There is a constant ratio between successive values. That constant ratio is denoted by the letter r, and we normally use the formula r is equal to T2 divided by T1. So determine the value of r, just negative 18, you divide by 36, then r will be negative a half. Calculate n if Tn is equal to that. For you to calculate n, then you've got the value of Tn. This is a geometric sequence, meaning the nth term of a geometric number pattern is AR n exponent minus 1. Therefore, you equate that nth term, where a is 36, where r is half, you equate it to 9 over 4096. And then you work out the value of n. AR exponent n minus 1 is equal to 9 over 4096. Then you work out the value of n. For you to work out the value of n, remember it's an exponential equation. We need to ensure that the bases are the same. Once the bases are the same, then we equate the indices. Then we equate the exponents. Thank you very much. 1.2.3, calculate the sum to infinity. For us to be able to determine the sum to infinity of any geometric series, that series must be convergent. And a convergent geometric series is a series in which r is greater than negative 1 but less than 1. Go back to your books, do a little bit of revision on sum to infinity. You'll see there is a condition which is very much important, a ruling that for a series to be convergent, r must be greater than 1, greater than negative 1, but less than 1. So we use the formula for sum to infinity, which is formula is a over 1 minus r. Sum to infinity is equal to a over 1 minus r. Remember, you don't have to worry much about the formula because in this test, the formula sheet will be attached at the back of the question paper. So all you need to determine the sum of infinity, determine the value of A is 36, the value of R is negative half. You then substitute and get your 2 marks. Thank you. Check 1.2.4. Calculate the value of more often. The last question on the topic will be a bit of a high order question. So all it requires, this one, you take all the odd numbers, 36, 9, you expand the series, so that you can have more, up to at least 6 terms. If you can expand to 36, negative 18, 9, our R in that case is 1 over 2. You keep on multiplying by negative 1 over 2. Then the series should be expanded. So you take, the numerator will be the odds, the denominator will be the even ones. So you check the type of sequence in the odds, you check the type of sequence on the odd. Sequence on the odd, R, determine the value of R, and then you determine the sum. How many times will be there? 250. Because all in all, you're talking about 500 terms. Denominator will have 250. 250 on top, 250 in the numerator, number of terms, and even the number of terms in the denominator will still be 250. Then you use the sum formula to determine the value of this ratio. It looks difficult, but definitely it is not that difficult. Because check the odd, expand them nicely, they will give you a geometric series. Then you work out the sum. How many terms will be there? Because you start from 1 up to 499. All in all, there will be 250 terms. Even the denominator, you start from term number 2 to term number 500. All in all, there will be 250 terms. So you already have n. All you need is R and A. A being the first term, R being the constant ratio. Then you work out the ratio. This is more or less what to expect on geometric. Remember, more often, again, even in geometric, more often, the sigma, questions relating to sigma. Let's hope I'll have time to show you one of those. Check question on algebra, on arithmetic. The first 3 terms of arithmetic sequence are 2p plus 3, p plus 6, and p minus 2. Show that p is equal to 11. An arithmetic sequence is a sequence in which there is common difference denoted by d between successive terms. So every time you say T3 minus T2 will be equal to T2 minus T1. When you substitute what? Every time you substitute, use brackets. Every time you substitute, use brackets. More often than not, learners tends to make a mistake of not using the brackets, and then that leads to a wrong answer. And once that answer is wrong, it becomes difficult to answer the subsequent questions, because all these questions are based on arithmetic. Now, because the value of p will be different, you end up with a sequence that is not arithmetic. I hope you get my point. Then it becomes difficult even to see a 3.1.2. It becomes so difficult. Let me say it becomes impossible sometimes, because you end up with a sequence that is not arithmetic. Thank you. Show that p is 11. I explained how to determine the value of p. We use the formula T2 minus T1 equals to T3 minus T2. And as you substitute those values, use brackets. And then it's easy to work out the value of p. And the value of p must be 11. Now check this one. Tn less than minus 55. It is arithmetic. Remember, the nth term of arithmetic is a. Tn of an arithmetic is a plus n minus 1 into d, less than minus 55. Now that you've got the value of p, you can work out the value of a, can work out the value of d. So it's easy to just substitute and work it out. Whatever answer you get, you will then, because it's an inequality, if n is less than, I'm making an example, if n is less than 15, therefore the correct value of n will be 14. Because calculate the smallest value of n. You want to know the value of n. What is the value of n? Because it's an inequality, you end up with n less than 27, for example. If n is less than 27, then the least value will be n equals to 27. check 2.2 is more or less a sigma. Sigma is not difficult. Sigma simply refers to the mean sum. Let me make an example of this one. You first substitute k by 1 here. This is the first number to substitute in the general term to determine the first term. 15 written up there is the last number to substitute in here to determine the last term. So already here, it's easy for you to get the first term and the last term. Remember this one, 0. That 0 represents sum. Sigma, sum. Sigma means sum. When you add all those terms, you start substituting k by 1 until you substitute k by 15. So all in all, the number of terms in that sequence is 15. So, but to make it easy, when you add them all, those 15 terms, they will give you 0. This 0 indicates sum. Then you work it out. I'm just giving you a hint on what to expect in this upcoming test. I've talked about quadratic pattern, I've talked about arithmetic, I've talked about geometric. And in both cases, I tried to highlight the critical points that we should prepare ourselves thoroughly for. So sigma is one of those. Definitely on the 19th of April, when you sit for that test, there'll be a sigma, a question that requires understanding or knowledge of sigma. And like I indicated, for you to answer a question relating to sigma, the first thing that you need to do, just expand. How do we expand? K is 1, substitute k by 1, and then 2, and then 3. You've got the 3 values. Then it's easy for you to work out the value of d and so forth. But once you have an equality sign like this one, this term written on the right-hand side of the equality sign, this one, in this case it is 0. 0 means sum. When you add all those terms from term, you expand by substituting k by 1, by 2, by 3, by 4, up until 15. When you add them all together, they should give you 0. This 0 represents sum. I'm just giving you an example of what to expect. I'm not saying this is the question that will be there, but something that involves sigma. Hence, I'm trying to emphasize more on explanation of what sigma is and how to solve problems relating to sigma. Every time sigma indicates summation, you add. So as you expand, the first thing that you need to do when you come across a sigma, expand the series. And as you expand the series, then you'll be able to tell whether the series is arithmetic or geometric. If there is a common difference, it becomes arithmetic. If there is a common constant ratio, it becomes geometric. And we know the formulae that we use to sum arithmetic or to sum geometric. For the last time, when you come across a question that involves sigma, expand the series to at least 3 terms. Once we have expanded it to 3 terms, then you'll be able to tell whether it is arithmetic or geometric. Then you use the relevant formula. Thank you very much. This is the first topic that will be tested on the 19th. Let me go to the second topic, which is Euclidean Geometry. The second topic will be Euclidean Geometry. There we are. Remember, in this year, Euclidean Geometry, how can I say this? It's a topic that is progressive. For you to be dealing with the grade 12 stuff, you must have learned all the previous theorems from the previous grades. Angles on a straight line, know the different types of quadrilaterals, all theorems, 9 theorems relating to the circle geometry, have that background information. But take note, for grade 12, you shall have discussed 2 theorems. It's a proportionality theorem. And then you are expected to know the proof thereof. Use the diagram below to prove the theorem. which state that if VW, here is VW, parallel to YZ, then XV over VY is equal to XW over WZ. You need to prove that normally around 5 or 6 marks. We call this the bookwork. Any CAPS compliant textbook has got the proof. Grade 12 learner, go and revise. Start construction. All the construction, you join or draw a line from V to X, perpendicular to XW, all those constructions, go through that. Prepare yourself for the proof of this theorem. It's a proportionality theorem. It's a possible question. Again, we can be expected to prove the similarity theorem. Let me take you through the similarity theorem. Sorry for that. This is more or less a similarity theorem. Thank you. In the diagram below, triangle ABC and triangle DF are drawn with angle A is equals to D, B is equals to E. Once they give you two pairs of angles equal, obviously the third pair must be equal. In this case, they've given you angle A equals to angle D, angle B is equals to angle E, and angle C is equals to angle F. It's given. But I'm saying sometimes they can only give you angle A equals to angle D, angle B equals to angle E. Then you, as a grade 12 learner, you must then know that the remaining pairs, angle C will obviously or automatically be equals to angle F. Then you need to prove that. I'm just showing you this to say it's a possible question. Go back to your textbook. It's a bookwork. The proof is there in any CAPS compliant textbook. Then you can revise that and as you prepare for the test. Thank you. I've said in Euclidean geometry, know the proof of proportionality theorem, know the proof of similarity theorem. From there, you must know all the previous grades theorems. Let me make an example of this one. I'm sorry. Sorry for that one. Let me take an example of this one. DF is a tangent to circle E. EKG is a cyclic quad. Once they say it's a tangent, DF is a tangent to circle at E. Here is DF. Then you must know three theorems. We have three theorems that talks about tangents. There is no shortcut to Euclidean geometry. For you to answer the question related to Euclidean geometry, you must know your theorems. Already, once they say it's a tangent, I think of two theorems. Tangent perpendicular to radius and tan chord. Tangent perpendicular to radius and tan chord. Because it's only just one line, hence I'm saying I think of two tangents. But if they were talking of tangents, it means they're in plural form, tangents. Then you bring in the third theorem, which is tangent drawn from the same point outside the circle are equal in length. You take that theorem into consideration as well. But now here they only talk of a tangent, one line. Because it's one line, two theorems must come to your mind. Tan chord theorem, tangent perpendicular to radius. They went further and say EKHG is a cyclic quad. EKHG, it's a cyclic quad. It's given as a cyclic quad. Then you must know the properties of a cyclic quad. Exterior angle of a cyclic quad is equal to the opposite interior angle, or the opposite angles of a cyclic quad are supplementary. Then it also boils down to angles in the same segment of a circle are equal. Know your theorems, grade 12 learners. Without knowing your theorems, you will not do well in this topic. All I'm saying is that this is the type of questions that you must calculate, you must expect. You see angle KEF is 35, here is KEF, here is that at 5. Then you calculate all these other angles. Determine with reasons the size of the following. If I were to make an example, E4, check E4. E4, this is the angle here, E4. Here is the angle E4. Thank you. How would you know EF? Because this line is a tangent. You already know that H3 H3 will be equals to 35 degrees, tan chord theorem. Now that we've got H3 as equals to 35, you have this side, KE, being equals to KH. So what that mean will then be, H3 will then be equals to E4, because those are angles opposite equal sides. Those are the angles opposite equal. Then you shall have calculated the magnitude or the size of E4. I'm just saying, grade 12 learners, get me well. Know your theorems. Once you know your theorems, you will do well in this topic. What type of questions are we going to expect? The proof of theorems, I've talked about it. Proportionality and similarity mainly. Of course, even from the examination guidelines, we've got six theorems, 4 theorems from grade 11 that we should know the proof of. They can also be tested, but I believe in this coming test is either proportionality or similarity theorem. Application, we apply all the theorems, like I'm trying to show you right now. Calculate EKH. Because you already have angle H3 and you already have E4, it's easy to work out EKH, which is angle K, sum of angles in the triangle. Every time, whatever information you get in 8.1, you use it to answer 8.1.2, and so on and so on. Know your theorems. From grade 8, opposite angles, what is that? Vertically opposite angles equal, all when you have parallel lines, all those theorems, you know them by heart. Once you know the theorems, you will do well in this topic. Without the knowledge of the theorems, I'm telling you right now, you are going to encounter problems in Euclidean geometry. This is an example of where we'll be expected to calculate the unknown angles. One angle given, then you calculate others, and so on. These are more or less where the angles are given in terms of x. Determine with reasons 4 other angles equals to x. This is more or less the type of questions that we should expect this coming Thursday. I need to make myself clear. I'm not saying these questions will be there, but I'm saying similar ones. Similar questions. First one, expect calculations like the previous activity that we just did, where one angle is 35 degrees, you're expected to calculate the others. This one, I'm saying one angle can be given in terms of x, then you try and identify other angles equals to x. Answer is simple. Know your theorems. We still can be expected again to calculate, use the proportionality theorem. Check question 9.2. It is further given that ED is to DC. Check ED. ED is to DC is equals to 8 is to 12. It's 8 is to 12. And FE, they give you the length of FE, they say is 10. FE is 10. Calculate the length of AF. How would you calculate AF? This is a simple application of the proportionality theorem. Remember, proportionality theorem states a line parallel to a side of a triangle divides the other two sides in the same proportion. Meaning DF here, DF is parallel to CA. So this line parallel to this side of a triangle will divide the other two sides in the same proportional. It will divide them proportionally. ED over DC is given as 8 over 12. Even EF over FA is still 8 over 12. But now, fortunately, if you've got the ratio of FE, it's easy to make it out. Grade 12 learners, expect questions on Euclidean geometry. And for you to answer questions on Euclidean geometry, you must know your theorems. There is no shortcut. Remember, the purpose for me being here today is to expose you to the type of questions that you should expect in this upcoming test. So I'm saying these are the type of questions that you should expect. Firstly, I said the proof of theorems. Secondly, I said angle given, then you calculate others. Then others you can express angles in terms of x. And the application of semi-proportionality theorem, this one is also to be expected. Lastly, similarity, where you need to prove that two triangles are similar. Check this type of question. Here it is, it's given that. Let me make it smaller. Thank you. In the diagram below, AB is a diameter. Once they say AB is a diameter, you must know your theorems. Immediately must know that angle ADB is 90 degrees. Because angle subtended by diameter is 90 degrees. Thank you. Fine, there is the given information. They tell you that angle B1 is equal to B2. Fine, both equals to Y, it's given. Prove that angle D4 is equal to 90. Must work out, prove that D4 is equal to 90. How will you prove that D4 is equal to 90? Know your theorems. The fact that it is 5 marks, it means you must work hard and apply your theorems correctly. Already we know that this angle D1 plus D2 gives us 90. You can express angle A in terms of Y, because this angle ADB is 90. So this 90 plus Y here plus angle A, they give 180 degrees, meaning angle A will be equal to 90 degrees minus Y. Now your right angle A is equal to 90 degrees minus Y. At the same time, you look at angle B2. Angle B2 is equal to angle E. You've got this, you are given that BD is equal to DE. So those are the angles opposite equal sides. Those are the angles opposite equal sides. So if angle B2 is Y, even angle E here is Y. Now, this one, this exterior C can be equal to A. Remember we said A is equal to 90 minus Y. So this C is an exterior angle of a cyclic quad equals to the interior opposite angle. So it means C is 90 minus Y. If you have 90 minus Y here, you've got Y here, it's easy to work out angle D. And if you work it out, sum of angles in a triangle, you will get D4 equals to 90. Here is the angle. Prove the similarity between the two triangles. Remember, grade 12 learners, already the angles are written in order. You zoom inside triangle BOD. What is triangle BOD? It means B in this case will be referring to angle B1. If you look at triangle BOD, this B represents B1. Check triangle BDE. Where is D? DE. Check triangle BDE. This B here represent B2. Firstly, so you already have the two angles that are equal. B1 is equal to B2. It's given. You just have to work out, find a reason. Why is angle O in triangle BOD, we are referring to O2. In triangle BDE, in triangle BDE, D here will be referring to D3 plus D4. These two angles must be equal. Find a reason. Lastly, angle D. What is angle? In triangle BOD, we are referring to D2. Must be equal to angle E. What could be the reason? The angles are already written in that order. B equals to B, O equals to D, D being equals to E. They are written in that order. All we have to do, just for any two angles, provide reasons. The third one will automatically be equal, sum of angles in a triangle. And once you have proven similarity, you can then work out the ratios. More often, as grade 12 learners, we encounter problems where we come across DE squared. Check DE squared. How would you arrive at? Because you've got DE, remember DE is equal to BD. So the moment you equate the two in the same expression, you can have DE and BD, so that you can then substitute BD by DE. I'm just giving you the scenario. These are the type of problems that you should expect. Prepare thoroughly. Thank you very much. Let me, for the remaining 5 minutes or so, let me take you through trigonometry. What to expect in trigonometry. grade 12 learners. Grade 11 trigonometry is unavoidable. I know for grade 12, we are only focusing on compound and double angle identities. Let me emphasize this. In trigonometry, for this test, 2D and 3D problems will not be tested, and the trig functions. Trig functions, 2D and 3D problems will not be tested. Other than that, any question on trigonometry should expect. For instance, sine of alpha is equal to minus 4 or 5, where alpha is greater than 90 degrees and less than 270. Without using a calculator, determine the value of each of the following in its simplest form. The moment they say without using a calculator, it means you must draw a right-angled triangle. You must use a diagram to solve this. Draw a right-angled triangle in the appropriate quadrant. Because sine A is negative, sine is negative according to cast diagram. It's negative in the third and fourth. So it's either we draw the triangle in the third and fourth. Now this restriction says alpha should be greater than 90 but less than 270. So it's either the second or the third. Then you can see you must draw in the third quadrant, because this one gives the option of third and fourth. This one gives you second and third. So the common quadrant will be the third. You just draw a right angle triangle in the third quadrant. This is a revision of grade 11 trigonometry. Grade 12, we studied the grade 11 negative angles. The sign of negative A, remember this negative alpha will then be equal to minus the sign of alpha. Reduce it, then substitute. Even this one, you can see the sign of alpha minus 45 degrees is a grade 12 concept, because it's a compound angle identity. You need to apply the compound angle identity for sine. Expand that. Expand this one. After expanding, and then you can immediately substitute. Already what will be involved here will be the special angle. And the question says without using a calculator. You see, you're going to have come across the sine of 45, the cos of 45. Then use special triangles to determine that. Thank you. Check again this type of problems, the identities, proving of identities. Take previous papers you prepare. You've got a textbook, you've got all these study aids, any material that is relevant, use it to prepare. But I'm saying these are the reduction formulae. Prove the identity for which values of x is in the interval between 0 and 180 will the identity be undefined. Once they say the identity will be undefined, think of two conditions. Tan, when is tangent undefined? Plus or minus 90. Then that will be the first condition. Second condition, when will this expression be undefined? If the denominator is equal to 0, check the denominator, equate the denominator to 0, and then solve. Equate the denominator to 0, and then solve. General solution. Cannot run away from a general solution. And for you to answer this one, 5.3 will then be expected to know expand the double angle identity here for cos, which can be expected in 3 different ways. Don't have to memorize formulae, because in the last page of the test, there will be a formula sheet where all this formula will be there. Teachers, let's expose our learners to all this formula sheet so that they get used to it. So as they write the test, now they know that once they come across like in this case, a double angle, they can easily refer to the formula to reduce that double angle identity to a single angle. This is what to expect in trigonometry. Check this one as well. If cos 34 is equal to P, without using a calculator, write down in terms of P. The moment they say without using a calculator, I always advise learners, you immediately need to draw a right-angled triangle. In that right-angled triangle, one angle should be 34. Remember, the other angle is already 90 because it's a right-angled triangle. It has got 3 angles. One angle is 90, the other one is 34. Then you can calculate the remaining angle using the sum of angles in the triangle theorem. Then you can work out the remaining angle. Then all this other angles, you must express them in terms of 54. I think the other angle here, remember we have 19, it will be 90 minus 34, it will be 56. The other angle will be 56. All these other angles, express them in terms of 56 and 34. For example, 240. 240 will expand, it will be 180 plus 34. Now we have 34. 180 plus 34. Check 68. 68 will be 2 multiplied by 34. It's a double angle identity. 2 times 34. Then you have 34. 56, already the other angle will be 56. Because in that right angle triangle that I'm asking you to draw, you've got 3 angles. It's a right angle triangle. The first angle is 90. The second angle is 34. The third angle will then be 56. Every angle that is given, express it in terms of 34 and 56, then you are sorted. This question also wants you to know the definition of trig ratios, sine, cos, and tangent. Thank you. The last one here was just the application of compound angle identity. It's cos sine, it's cos sine, it's cos cos. Use the reduction formulae so that at least you have cos cos, sine sine, or you have cos sine, then it becomes easy for you to simplify it. So that are using the compound angle identity. Trigonometry. I repeat, this type of problems where you need to draw a right angle triangle will definitely be there. This type of problems where a diagram can be drawn like this one will definitely be there. Let's prepare thoroughly. General solution, special angles, and simplification of trig ratios, you must know. And the key for you to master this, revise grade 11. After revising grade 11, know your identities, including the compound and double angle identities. Grade 12 learners have come to the end of the session. The main purpose of the session was just to highlight to you what to expect in this upcoming test. The test will be set on 3 topics: patterns, sequences, and series, Euclidean geometry, and trigonometry. And the test will be written on the 19th of April. I hope the information that I've shared with you will help you to prepare thoroughly for a test. It will be your first official test, a first formal test for 2021, a first formal task that will be contributing towards your SBA. It's very much important. We need to perform well, because once we perform well in this test, we'll then boost our confidence in the subject. And if the confidence is high, chances of you performing well are very high. But once you do not perform well, you become demotivated, you start developing a negative attitude toward the subject, then it means your performance in the subject will not be well. And remember, country needs learners who have done mathematics. All these lucrative careers, they require learners who have studied mathematics. So you need to be prepared thoroughly. On that note, let me wish you well in the test, and I thank you for today. Good luck.